Well, good morning, and we're looking here at kind of what amounts to a production approach that makes sense. Um, we can start out with this kind of a piece now and kind of cruise along. And I'm still kind of in this mode, unfortunately, where I am, how would we put it? Rough. David is very rough. But I had somebody who I guess I could call a fan. And I'll have to ask my fans if they want to be named. But she asked me, she said, why do you speed your voice up? You can always add your voice later. And I had to explain, well, it's because these are still rough. Yes, I know. Speeding up my voice may seem a little bit silly, but I like to casually go about this part of what I'm doing. So I sound kind of slow, kind of almost dumb while I'm doing this. And then I speed it up and then I sound like a slow, almost dumb guy. How would I put it? The slow, almost dumb guy. Speed it up. See there, how's that for eloquence? Okay, so what I've got here is I've got a landscape I'm kind of happy with. And these are going to become coloring pages, panels, comics, all kinds of things. But there are scenarios. So let me explain what's going on. This is we can write all over this. We can always put things in here. So this is a planetoid, right? We all, now the history of planetoids more or less, right? Okay, that's good. I think I've explained it about 10 times. Okay, so now we know about the planetoids. And what they have happening is this issue in one of the information ages. What happened was they learned how to control the concentration of mass in extremely small areas, which affects gravity, right? So, I don't know, maybe it's with quantum particles. I have no idea really how they did it, but what happens is they were able to move mass around or move gravity around in an interesting fashion. So I have all these little rules for gravity, just like I have rules for time travel. I have rules for gravity, rules for time travel, right? Which we'll discuss later. Anyway, so what's happening here is the planetoids, what they have is well, they're hollow. So if you can see what's going on here, we're looking at the outside surface of a planetoid, right? And what's happening is this is a waterfall, and it's going through a gate, right? And these gates, oh, I did this. Oh. It's easy enough to fix it. Okay, so anyway, what happens is they open the gate, and all this water, which is held on the surface of this planetoid, is going over the edge, falling deep down into the planetoid. And so that's what this is. You're looking at vast areas of water, maybe an ocean up there. And what happens is it's now going over the edge here where the gate opens up, right? How do I put this? Well, these are the kind of things that we learned to do. So why not? Oh, tracing paper. That's what all this is about. We don't learn how to use tracing paper. I was going to say idiot, dimwit, whatever the word is. I often will forget exactly why I'm doing what I'm doing when I'm doing it. And so anyway, yes, we're going to use tracing paper. So that's what that's why I'm doing this hard, to show you how to use tracing paper. So what? Yes, we can do these things and drop them in place. We're using tracing paper. Okay. This is an adventure. Okay, and so what we're looking at here is we're looking at this little craft. I don't know how small we'll make a little craft, but it's a little craft. The tiny ship was tossed. The minnow. This is the minnow, and the minnow is about to go over the edge. Darn it. The minnow, which is being tossed upon the waves of this ocean, which is going over the edge of the cliff of the planetoid. That's good enough for now. That's what's sitting right there. Yay! It's going over the edge. Now, so we want on the tracing page side, what we do is we figure out kind of where the lines go. So, one of the things, and this is how to draw part, is that in reality doesn't work this way. Sort of like in Star Trek, even in what it was, the second generation, nobody talked over each other, right? If you notice, even in the middle of a battle scene or something, right? The people in that universe never talk over each other. Very seldom do you hear a bunch of people talking at the same time in Star Trek: The Next Generation, right? But the real universe, things are talking over each other constantly, right? That's just what it does, I guess. And so it goes with, in reality, there's infinite depth, right, going on here. There's something on the floor, and then there's something underneath that. It goes on and on and on. In this, well, that took care of all the space. It's right there, and now it's filled up with that. So remember while you're drawing, and making stuff up, that you have a fortunate situation of filling the space up, right? So I don't need to worry about any of this anymore because that's what's in this space, right? I define that. So anyway, I don't know what that's good for. Okay, so now we have to decide how far away this is. I'm going to keep this very simple. We're not going to get complicated. It's about the same distance away, okay? Meaning that the wall would be like that. Okay. So what are we indicating here? The planetoid. I created what? Oh, I had the structure that kind of defines, how would I put it, makes this look kind of cool. This is not a phallic structure. At least not consciously, it's not a phallic structure. It just happens to be something that's kind of jut out from here. Okay, let's figure out how the wall is, right? Anyway, we'll do that. That looks kind of cool. It's still a bit rough. We want to have, I guess, we want something interesting to go here and something interesting to go here. That will take a little bit of work, and I'll show you how tracing pages are good for that. For now, again, something kind of interesting here, right? That shows the scale. So what we're dealing with is little cities, right? So that kind of helps. So okay, so that helps. This is like a little city kind of thing happening here. A little city on top of this thing. Okay, little city kind of thing happening here. That helps. Okay, so the little city kind of goes like that. And then creating what amounts to detail that's interesting, working its way around that. And I suppose that this would be kind of city stuff kind of jetting out here, right? And we might as well make this interesting. So this is what I mean by these compositions. They come together and kind of cool stuff happens. So this, in terms of scale, this literally has to be like a cruise ship. Right? This is no longer the middle. This is now some giant cruise ship, which makes it interesting because we have all kinds of people who are on the cruise ship, and they're about to go over the edge and fall into this or whatever, into the planetoid, over the edge. There they are. Meanwhile over here, okay, we have this happening, which is another part of the city. But I'm going to run out of time if I'm not careful because I can't compress my voice past this. So what we have is there's atmosphere and the stars. The atmosphere and the stars over here, right? And so the planetoid kind of goes like this. Now, there's this thing called tangents. You have to be careful with tangents when you're drawing. And I'll explain tangents more later another time. But basically, if I have something sweeping through here, which is the edge, the interior of the planet, this back here someplace, it's an awkward tangent. It's an incredibly awkward tangent. This line kind of needs to go like that. Oh well, we'll figure it out later. That is awkward. Okay, so what happens though is that we're looking through the planetoid, so we see the atmosphere, which is this atmosphere, kind of on the other side. Okay. You can see how these would be really fun colored things. And we have a planetoid up here. Okay. And planetoids. Remember, there's millions of planetoids in the rings of Jupiter, right? And this issue of moving the mass around. Okay, so very quickly, about 3 years ago, I ran into this really beautiful exchange student who we translated one of my stories, kind of like about this stuff, into Japanese. And then she disappeared. She was a Facebook friend, but she doesn't really answer my messages. So I need to find out what the protocol for that is. I want to use the translated material, which is kind of cool. But what is the protocol? I've tried to reach her several times. Is it bad manners to use it, or is it a compliment to use the translation? I'm not sure. So anyway, I'm just mentioning that because there are people who have taken interest in the project over the years, but often they'll just kind of vanish. What happened to that person? So anyway, what happened was we translated this really cool story called Tides. And what it's really neat because what happens is, because they can move the mass around the planetoids, the weight. Imagine if all of a sudden you could control the rings, the actual real rings of Saturn, right? Because you're controlling the mass of what's going on inside the ring, right? So and then you start doing other things. Well, these planetoids have water on them because that's what they were doing. They were taking the elements on Jupiter and adding things and moving them around. They created a bunch of planetoids with water. Damn, another awkward tangent. I just created another awkward tangent. Hooey. That is, this is the flow going on the water against the curvature being indicated on the inside here, which is going the same direction. Damn it. And it works better if the curvature, which is a little more complicated to figure out, is actually going the opposite direction. Okay? And you'll see that really quick. So I'll just do that, just to show that the effect is actually pretty cool. There's a curvature going behind here, right? So very quickly what I'll do is I'll just draw curved lines. Now remember, this is for tracing, this is going to get refined, and I don't know how soon I will do that video for refining. Now that's running into the awkward tangent. This. See, there's complicated things to think about when you're composing stuff. You want, in the end, you want it all to look pretty darn cool. Now, so opposing direction for different distances is one way of doing this. As far away as up close. The lines indicating this are going in this direction. The lines indicating that are going that direction. My wall has to run around and end up kind of here. And I have a wall I have to figure out. It's going off into the distance. So the opposite direction would be this. So let's just throw that in there really quick. The opposite direction here would be this. So let's throw that in here quick. We were kind of the opposite direction here would be this. Notice how we're figuring that out. Now, this probably wouldn't go directly into this. It's hard. We'll keep it that way because it's too hard to fix. But you can see how, sometimes you just have to go, well, leave it like it is. Nobody's really going to. I noticed this is odd. It goes directly into this. So in the tracing somehow, I will have to actually put a piece of paper over this and figure this. This is going off into the, oh, you know what? I just took care of it. This happens at a much larger scale, much faster. Okay, so that kind of takes care of it. Then we have shadow lines kind of going underneath there to show that that's what's happening. Okay. Now, over here on the horizon, way out in the distance, come on, don't do that. We have other bits of something going on out there. Okay, and that could be where there's another wall or something else is going on. We don't really know. Okay, I have a feeling the video's now about to get long. We've indicated some stuff. That's pretty good. Okay, so what happens is we have characters, and right about here in the foreground, we have our robocar. And I'm just basically putting this guy in here, right? And we'll figure this out a little better. If you've been paying, these characters actually do have, they're more than just placekeepers. They actually are characters. That's the robocar looks a little bit silly here. Robocar, okay. But we have silly and unsilly robocar. Okay. Again, this tangent needs to, he's coming to here. Keep your lines kind of right, okay? It's not too far off, but it's a little. Then I've got this thing going on where this is saying something, okay? This is a character, the robot in the back. And I don't know if you've ever seen Ran Xerox, which is just this fantastic Italian sci-fi comic that came after Mobius, who's French. So Mobius and the other guy who started Heavy Metal were fantastic. And then this other guy did this comic called Ran Xerox, which was kind of the same dystopian thing. But his robot was talking, it's like goofy with symbols and stuff. So this robot kind of does stuff like that. Here, characters on the boat are saying something. I don't know if I want to, do I want to cancel that out? No. So, okay, I have another awkward tangent that needs to be figured out with that. Now, see how all these tangents run into each other? This is what you need to figure out with tracing. In a good composition, the tangents do not mess up. There could be, again, reality, tangents mess up all the time, but in this situation, when you're composing something, one of your goals is to make all the tangents look good. Okay, so this has kind of an issue of something needs to be going on. Now we'll get into something later about composition, points of interest. Remember, at any, a lot can be going on here with lines and other things. And if I really feel, this is not working because there's too much empty space here, I can drop a city right there on an island maybe. For now, I'm going to leave it open. And let's see, we know the dark sky goes across like that. And then we have little stars, things happening, planetoids, etc. And then I put a planetoid here. Now, see, that's awkward space. Somehow a planetoid that's a different size and all of this kind of. And I'm going to show you some effects for making things look cool, like they're in the distance with atmosphere and other things later. That planetoid looks awkward. Oh, you know what's wrong with that planetoid? It looks like it fell off the cliff. It's a little tiny planetoid in the middle of the cliff. We either have to fix that by making it look like it's way off in the distance, or we have to give up on it altogether because we want to keep this feeling of this coming across like this. It would be great if there was a planetoid kind of like off in the distance there. That's not what's happening. Okay. I'm just doing this because it's kind of cool. I don't know if I'm going to keep that or not. So those, do that. We know, I just don't want to put shoreline or anything. In fact, shoreline is kind of the name of this series here. tides, shoreline. The whole idea of here on Earth, amazing things are going to happen with water. But anyway, so there's this whole story about how the water on the planetoids moves around as the planetoids move because the mass is being moved, etc. Or gravity is being moved. And that just makes for a really cool story. Now, I never read it, but Herman Hesse wrote a book called The Glass Speed Game. Glass Speed Game. It sounded really interesting, but I never read the whole book. Anyway, this could be the glass speed game of planetoids and moving mass around and stuff like that. That could be kind of interesting. So this is the shoreline. Maybe a bit of narrative could go here. See, this is how things make themselves up. You got this awkward space. You don't want to end the space. You want it to be the ocean, the empty ocean, but you still want something there, right? Which means you either have to have something that's above the ocean, way up high, like way in the foreground, and I'll put this foreground or narrative for this, right? It's a decision that has to be reached. Foreground or narrative for that. This looks a little bit spastic. Excuse me. It just looks like it's just not. It's not balanced. Something's wrong with this. It would be cool if there were cranes and things going off this direction or something, but it looks like somebody just tapped the top off that thing. So we'll leave that like now. Maybe having something kind of going like that would be good. I don't know. That makes it look a little better. So hopefully that didn't take up so long. My compressed voice sounds crazy, but that's the composition. This is our piece for the day. Here we are. That's great. And let's see how this went. Thank you very much.